Great, this is the review for Unit 2, Part 2. I'm going to use the honors version. Um, some of these problems are on each of your worksheets. You'll just have to sort through and find the particular problems. Honors has more problems, and first and third have less, so you'll just have to find them. So this first one is saying solve quadratics by graphing x squared plus 10x plus 24. So you could graph that in your calculator and see that it has an x-intercepts at both -6 and -4. It has a vertex at -5, 1. And it is, nope, that would be -5, -1. Sorry. It's opening up. The y-intercept is way, way up at 0, 24, so it would be hard to graph that part. You got your -4, 0, your -6, 0, and your vertex of -5, -1. You can also do that stuff algebraically. You can factor to get your x-intercepts. You can put it into vertex form to get your vertex. And you can plug 0 in for x to get y-intercept. The next one, we've got an x-intercept at -2, 0. We have one at 0, 0, and it's also the y-intercept. Vertex is at -1, +3. It is opening down. All right, next is asking us to solve by factoring. So we're going to go ahead, factor x and x. Factors of 18, that would add to give me 11. That would be 9 times 2. 2 negatives, same sign. And then we split them and set them equal to 0. So here we're going to add 9. You get x is 9. Over here you're at 2, and x is 2. I'm just going to kind of go through this quick, so pay attention. Next one has a GCF of a 2, so you've got x squared minus 16x plus 64 equals 0. Then continuing the factoring, we have identical twins. 2 cannot equal 0, so that's out. And since you've got twins, you only have to solve this once, add the 8, and x is equal to 8. Now, if I'm going too fast, just ask Mr. Weaver to pause it. Number 20 here, GCF 2x, 4x plus 5 equals 0. We've got 2x equals 0, which you divide by 2, and x is 0. Over here, 4x plus 5 equals 0. Subtract your 5. 4x equals -5. Divide by your 4, and x is -5/4. The next one, we've got a harder trinomial. It's got to have different signs. That's going to give me 19, and I have to find the right combination between the factors of 7 and the factors of 6. So ended up with x minus 3, 7x plus 2. So then splitting them up, this one's going to be x is 3. Over here, you got to move that 2 first by subtracting, and then divide by the 7. So that one would be -2/7. So there's your x-intercepts, your zeros, your solutions, your roots. And you have all those different names. Now we've got converting from standard form to vertex and to factored. So 22 gives me the standard form, which, remember, that gives me my y-intercept. So that's 0, 63. my vertex form, keep my x squared and my 16x, knock out 63. We need to replace. So you take half of your 16, the number with x, which is 8, square it, you get 64. So 64 needs to go inside, minus 64 goes outside. Now we go ahead and write this in factored form. We would have x and x, 8 and 8, a plus, squared because there's 2, the identical twins, and then we have a minus 1. So it asks for our vertex, so it's opposite h, comma k, so that would be negative 8, comma negative 1. And it asks for our axis of symmetry, that's that invisible line that comes down. Well, that is going to be at the negative 8 because our vertex lands right on that axis of symmetry. Factored form, let me put function there. Factored form, this one was an easy one, x plus 9 and x plus 7. That's what it looks like in factored form. Identify the roots, so you're solving, you're taking x plus 9 equal to 0, x plus 7 equal to 0. So one root is negative 9, and the other one's negative 7. So you would write those as negative 9, 0, and negative 7, 0. So 23 gave it to you in vertex form. So it would be good to get it into standard form first, but let's go ahead and identify the vertex opposite of h, comma k. So that would be 2, negative 25. The axis of symmetry, again, is that opposite of h. So that would be x equals negative 2. Positive 2, sorry. You can also find it if you do part of the quadratic formula and do the opposite of b over 2a. That will also give it to you. But you would need it in standard form to do that. So to get it into standard form, write it twice. You will do the lobster. Combine like terms. And you got x squared minus 4x minus 21. Again, this would be your y-intercept, so that would be at 0, negative 21. If you take the opposite of b, so that would be 4 over 2 times your a, which is 1. 4 divided by 2 is 2. So that would also give you your axis of symmetry. And now we need to take it into factored form. So use the standard to get you to factored. We've got f of x equals x minus 7, x plus 3. There it is in factored form, and that gives me 7, 0 as one of my x-intercepts and negative 3, 0 as the other. Solving quadratics by square roots. All right, so you're going to solve these as if they're, well, if you notice, none of them have an x. They all have just x squared and numbers, no x. So you can solve it simply by moving things from one side to the other. So here I'm going to add 1. I've got 16x squared equals 1. Divide by that 16. X squared equals 1 over 16. Our next step then would be to square root. Whenever we square root, remember the square cancels and a plus and minus comes out of that. So x would equal both a positive and negative. 1 is perfect, so that would equal 1, and the square root of 16 would be 4. So positive 1/4 and a negative 1/4. Number 25, subtract that 11. Negative 3x squared equals 6. Divide by negative 3. X squared equals negative 2. Last step, square root. We have a negative. We're going to pop out an I. Pop it out. pop out an I, just like Glenn. All right, so we go ahead and we've got x equals both a positive and negative. There's my I popped out. 2 is not perfect, stays under the square root. Number 26, we're going to square root both sides first. So we got x plus 5 equals both a positive and a negative 2, because square root of 4 equals 2. Now we got two problems here. We've got x plus 5 equals 2 and x plus 5 equals negative 2. So go ahead and subtract your 5. So x is going to be a negative 3, and over here x is going to be a negative 7. So there are your x-intercepts, or your roots, your zeros, your solutions. Okay, 27. Got to move that 7 first. Add it to the other side. We've got x minus 8 squared equals 32. Now what? You're right. Square root. We've got x minus 8, don't need the parenthesis anymore, equals both a positive and negative square root of 32. Next, I need to get rid of my 8, so I'm going to add it to the other side. X equals 8 plus minus square root 32. Now, you should go one step further. Look at the square root of 32. He is not perfect, but check your square root list and start going through and see if there is a square root hiding in there. And 32 is 16 times 2. So there is the square root of 16. We're going to go ahead and take that square root of 16, make it a 4, so it comes out as 4. Do not put the square root back around. But 2 isn't perfect, so he stays under the square root. So our answers are x plus 4 root 2 and x minus, or 8 plus 4 root 2 and 8 minus 4 root 2. Next are, the quadratic functions whose roots are. Now this would be for 4th period and 1st period. Remember, we're going backwards. So they're telling me x is 1/3 and x is negative 5/6. I've got to undo this. So I'm going to first multiply by 3. So now I've got 3x equals 1. Now I've got to subtract 1 because I'm bringing it back. 3x minus 1 equals my 0. Over here, I'm timesing by that 6. 6x equals negative 5. Add 5 to bring him back. So 6x plus 5 equals 0. Now we need to put it together. So 3x minus 1 and 6x plus 5 equals 0. There it is in factored form, but go ahead and put it into standard by doing your lobster claw. So we've got 18x squared plus 15x minus 6x minus 5 combined. So 18x squared plus 9x minus 5. So there is the equation. All right, the next one, this one's not as long. X equals negative 8 and x equals negative 9. Tell it to come on back over, add 8. So I've got x plus 8 equaling 0. Over here, I've got to add 9 over to bring him. I've got x plus 9 equals 0. Bring them together. And we've got our quadratic in factored form. Go ahead and put it into standard by lobstering. And combining like terms. So x squared plus 17x plus 72. Now, if I add or subtract wrong, I don't have a calculator in front of me, so bear with me. Okay, next one. We've got a positive and a negative 11. That just means we've got two answers. They're the opposite twins. We have one being 11 and one being negative 11. bring them back over by doing opposite operation. So this would be x minus 11. This would be x plus 11. And if we put it together, set it equal to 0, we've got our factored form. Go ahead and lobster. So we'd end up with x squared plus 11x minus 11x minus 121. And last step, combine. What happens to those middle terms? They cancel. So I've got x squared minus 121. 4 and 7. So x is 4, x is 7. That gives me x minus 4 times x minus 7. Because I have to bring them over by doing opposite operation. Then do my lobster claw. And combine your like terms. And there it is. X squared minus 11x plus 28. Okay, solving quadratics by using the quadratic formula. So here we go. We're going to sing our opposite of b, plus or minus square root b squared minus 4ac all over 2a. All right, so make sure you label first. We got a is -1, b is 3, and c is a -21. So x equals opposite of b, -3, plus or minus square root b squared, 9, minus 4 times a times c all over 2 times a. Now I'm going to need my calculator here. All right, we're going to do what's under the square root first. So you're going to use calculator, do 9 minus 4 times -1 times -21. That gives me -75. All right, so a -75, let's see where we're going to go with that. We've got, well, what is it going to be over? It's going to be over a 2, right? A -2. Okay, so is 75 perfect? No, you say. Is there anything perfect in it? First of all, there's negative under there, so we're going to pop out an I. 75 has 25 times 3 hiding in there. So 25 is a perfect square. That'll come out as a 5. So x is equal to -3 plus or minus 5i root 3 all over -2. They can't be reduced any further, and the only thing that might be different is you may have a +3 and a +2 if you rearranged and changed your signs at the beginning of the problem. All right, 31. A is 10, B is 8, and C is -1. If you list it this way, with A, then B, then C over top of each other, it might help to keep track of which numbers you're using. X equals opposite of B, plus or minus square root, B squared, so 8 times 8, 64, minus 4 times 10 times -1, all over 2 times 10. So, let's find that number under the square root, which is 104. And that's all over 20. Well, 104 is not perfect, but I'm going to go through my list. 100 doesn't work, 81, blah, 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 all the way to 4. 4 does go into it 26 times. So the square root of 4 comes out as a 2. X equals -8 plus minus 2 root 26 all over 20. And then you'll notice that all of those numbers that are outside of the root can be reduced by 2. So your final step, x equals we have to divide by 2. -4 plus minus square root of 26 all over 10. And that's it. Can't reduce that one any further. So we've seen imaginary numbers, we've seen irrational ones that are real ugly, and then we've seen some answers that have come out nice. All right, so the next part, discriminant. Honors class, we talked about the discriminant. That's the part that's under the square root. That's the b squared minus 4ac. And if you use that and plug your numbers in, you can find out just how many roots or answers you're going to have. So if I plug it in and I get a square root of 0, that means I'm only going to have one answer. If I get a square root of a negative number, then I'm going to have no solution. And if I get a square root of a positive number, I'm going to have 2 solutions. Now, math 1, or first period, you did not do the discriminant, so you don't have to do this part. And math 3, period 3, excuse me, you don't have to look for discriminants. All you need to do is go ahead and solve these in any method you want, and then state which one. F for factored, SR for square root, CS for completing the square, and QF for the quadratic formula. So in number 32, I'm going to say factor. That looks like it's going to be an easy one to factor, less work than having to do all that other stuff. So we've got x and x, factors of 8 that will add to give me 2. 8 and 1, 4 and 2. Okay, so we can't factor. We are going to have to use the quadratic formula. So, circle that. A is 1, B is negative 2, C is 8. And here we go. So we've got x equals opposite of b, so 2 plus or minus square root b squared, 4 minus 4 times 1 times 8, all over 2 times my a. Now, honors, as soon as you get this under here, that 4 minus 4 times 1 times 8, let me check what that is real quick. 4 minus 4 times 8. So you get a negative 28, so that tells me my discriminant is negative 28, so I'm going to have no solutions here. But we're going to still solve it and pop out an I. So, for the rest of us, let's continue. 2 plus or minus the square root of that negative 28 all over 2. 28 is not perfect, but there is something perfect in there. We're going to pop out an I because of that negative. And let's see, 28. 4 goes in. 8, 16, 20, no, 6, 12, 18, 24. No, 9, 16. Okay. I don't think we have anything that's perfect that goes into 28. So, wait. No. What about 4? It is 4. 7. 7 times 4. So, this is going to break into 7 times 4. 4 is your perfect square, which becomes a 2. He comes out with the I. 2 plus or minus 2I root 7 all over 2. And then, warning, there's all 2's that can be divided. So you divide each of these by 2, and you'll see your final answer is 1 plus or minus I root 7. All right, moving to the next, number 33. First of all, we've got x squares on both sides and numbers, so let's try and get things together. We're going to move that negative 2x squared over to the other side, so he's not negative anymore. So now I've got 8 equals a 3x squared minus 28. So do you think I could solve this from here doing roots? Square rooting it? Since I don't have an x, let's go ahead and add 28 over to here. So 28 plus our 8, 36, equals 3x squared. Divide by 3, And x squared is equal to 12. Now I square root. So x is going to equal both a positive and negative, square root of 12. Now, of course, 12 is not perfect, but that funny little 4 seems to pop up everywhere. Square root of 4 is a 2. So x plus or minus, bring out that 2 and keep your root 3. So x equals both a positive and a negative 2 root 3. For the discriminant for honors, once you got those into the right place, the discriminant doing the opposite of b, doing b squared minus 4ac came out to be 1600. So you would have 2 solutions, and you can see from our answer that's true. All right, 34. For this one here, we can do quadratic formula again. I'm not real sure it would factor very nicely, so let's go ahead and just go for quadratic formula. So a is negative 2, b negative 5, and c negative 4. And go ahead and plug or check to see. I'm going to take a moment here and just write. Okay, so now I've got 5 plus or minus the square root of a negative 7 all over negative 4. So, honors, there's that discriminant under there of negative 7. Since it's negative, we're going to have no solution. But we can pop out an I. So we're going to go a step further and show what the imaginary answer would look like. Pop that I out. We got 5 plus or minus I root 7 all over negative 4. And nothing else can be reduced. Hey, 35. I can do this one by factoring. But first, for honors, we want to check and see what that discriminant is. So when we take b squared, which is 1024, minus 4 times negative 36, that gives me a 1600. So that tells me I'm going to have 2 real solutions. Now, let me go back one step here to number 33. I accidentally said that the discriminant would be 1600. It is actually 432. So I'm sure y'all were going, wait a minute, that's not what I got. So sorry about that. Okay, so we're going to get 2 real solutions. We're going to go ahead and factor. Well, you can see we can take a 4 out of this. So we've got x squared plus 8x minus 9. Right? Go ahead and factor now. So factors of 9, that will subtract to give 8. That's, of course, 1 and 9. We need a positive 8, so positive 9 minus 1. 4 cannot equal 0. X minus 1 equals 0. We add our 1. So x is 1. Over here, for x plus 9 equals 0, we subtract our 9. And there's our 2 real solutions of 1 and negative 9. All right, the chicken coop at the petting farm is 10 by 14 feet. The farm would like to double the current area by adding the same amount x to the length and width. What are the dimensions of the new enclosure? Round to the nearest hundredth of a foot. All right, so this problem is for honors. So if standard, you can skip over this problem and go on to number 37 if you want to fast forward, or unfortunately just listen to me. So here we know that the length is 14 feet, and we know that the width is 10. and they want to double the current area by adding the same amount. So we're going to add an x to both of those. They're telling us that we have to double our area. So our area to begin with, when it was 10 by 14, was 280. So to double that, we're looking for, no, 10 times 14, 140, doubled is 280. Sorry. So this would be 140, but we want to double it, so we're looking at 280. Okay, so length times width gives me area of 280. I'm going to go ahead and lobster claw, and then be sure you bring that 280 over to the other side. So you would end up with x squared plus 24x minus 140 equals 0. You go ahead and do your quadratic formula. You'd end up with x equaling negative 24 plus or minus square root of 1136 all over 2. Since this is a real problem, we're actually going to do the square root. So in your calculator, you do negative 24 plus square root of 1136. Enter, then divide by 2. Make sure you hit enter before you divide by 2. All right, and so one of our answers is 4.85. Then I'm going to do negative 24 minus square root of 1136. Enter, divided by 2. And that gives me like negative 28.85. Well, that x, since it's length and width, can't be negative. So 4.85 would be my x, but that wasn't the final question. It said, what are the dimensions? So you'd have to go ahead and plug 485 back in to the original, and you'd find out that the enclosure would have to be 18.85 feet by 1485 feet. All right, Natalie found a tennis ball outside a tennis court. She picked up the ball and threw it over the 12-foot fence into the court. The height of the ball, h, and the time t seconds is given by the equation h of t equals negative 16t squared plus 18t plus 5. Will she make it over the fence? Now, everybody has this problem, so we can take a look. If we want to know if she makes it over the fence, then we are looking for our max, which is our vertex. An easy way to find it would be to use part of the quadratic formula. X equals the opposite of b over 2a. Or you could graph this, fix your window so you could see it right, and then use trace to head on up to that maximum. Once you're in trace, you can hit second calc and pick max, and then you do the little left, the right, the enter, 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 and it would give it to you. So we're going to do the algebra. Opposite of b, negative 18, over 2 times negative 16. This is going to give us 0.5625. So that's our time. This is seconds when it gets to its maximum. We want to know how high it's going to be, so we've got to plug that back in to our equation. So negative 16.5625 squared plus 18 times 0.5625 plus 5. And that gives us approximately 10.06 feet for the max. And that fence is 12 feet. So no, she will not make it over. So that's a big no. All right, Jack was so frustrated with his slow laptop that he threw it out of his second-story window. The height h of the laptop at time t seconds can be given by this equation. Assuming the laptop hits the ground below, how many seconds will it take to hit the ground? So if we are wanting to know how many seconds, we want to know t when it hits the ground, which height would be 0. So we are looking for our x-intercept. We want to know when it's going to land. So we can go ahead and set this equation equal to 0. Notice he was 17 feet up on the second story window. That was 17 feet high. He threw it at a velocity of 28 feet per second. And of course, then you've got your gravity pulling it back down. So we're going to use our quadratic formula. In this, we'd have x equals, I'm going to cut it to right to what it would be as you simplify. And now, since it's a real problem, you would take negative 28 plus square root of 1872, hit enter, and then divide by your negative 32. So we would get a negative 0.477. Then do it again, but subtract. We would get a 2.223. Y'all might round it a little bit different, but as long as you're close. So it will land 2.223 seconds later. So as long as your answer is right around that amount, you'd be right. All right, the table below shows the altitude in feet of an airplane at certain times during its flight from Baltimore to Orlando. Now, honors and Math 1, you guys keep saying Math 1. Period 1 have this problem. So let's take a look here. Make sure that you changed your time. This would be 11 o'clock. This would be 11.5 because 11:30 is half of an hour. Then you've got 11 and 0.75 because 45 minutes would be 3/4 of an hour. 12, 12.5, 12.75. So you do need to change that for your L1 before you put it into there. So remember, you're going to use your stat edit, and that's all on your notes. So you can look back at that. Put your L1 and your L2 in. The altitude depends on the time. Once you get it into there and you choose quadratic regression, your equation would be somewhere around this number. Yes, this last one's really, really, really long, and I'm going to run out of room. Okay, so there's the crazy equation for the altitude of this plane. And we want to predict it at 1 p.m. So all you'd have to do is go ahead and wherever you've got an X, you're going to plug in 1, which makes this problem super easy. But is it 1? Wait, we talk about military time. So am I putting in 1? No, 1 o'clock would be 13 hours. So I've got to put in a 13. So be careful, don't make that mistake. All right, so use your calculator, plug it all in, make sure you use your parentheses, and y is going to equal 3254.04 feet. Your answer should be somewhere around that. Okay, next. Consider these two equations. Now, this is for honors. You've got y equals the 3x plus 2. You can read through what is one solution to the system of equations. So our one solution would be, you could have, this would be x is 1. This is x equals negative 8. But you need their partners because you're looking for the coordinate where they cross. So you'd have to then put 1 back into one of your equations, which seems to always be the linear one. That's easier. So one of your points would be at 1, 5. And then you plug negative 8 in. So you get negative 24, 22. So you could have either one of those answers. All right, the next one says to solve. Now, since they're both set equal to y, I'm going to go ahead and set them equal to each other. All right, now let's get everybody to one side. So add that 5x over, subtract that 5, 3x squared plus 5x minus 2 equals 0. Don't think you could factor this, so you would have to use the quadratic formula. So we've got let's figure out what's underneath that square root. So we have a 25 minus 4 times 3 times negative 2. And that gives us a 49 all over 6. So now 49 is perfect. It's going to come out as a 7. You got two problems here. You got negative 5 plus 7 over 6 and negative 5 minus 7 over 6. So here we've got 2/6, which is a third. And over here, 7. Negative 12 over 6, so negative 2. So those are our x's. But now we need to plug them back in to get their partners. So I'm going to plug it into the linear one again. So 1/3 in here. I've got 5 minus 5 times 1/3. It's going to give me 5 minus 5/3. And 5 minus 5/3, let's check out what that is. Oop. I'm using my calculator, you can't see me. That would be 10/3. So what are my coordinates where they intersect is at 1/3 and 10/3. Then I plug negative 2 in, and I end up with a 15, I believe. Yep. So negative 2, 15. Those are the 2 points where the quadratic and the linear equation intersect. Okay, look at this graph of y equals x squared. If you had y equals x minus 2 graphed on the same one, how many points would the two graphs intersect? Well, first we'd have to draw it. The minus 2 tells me of a y-intercept at negative 2. My slope, 1 over 1, so I'm going to rise 1, run 1. Rise, run, rise, run, rise, run. And I could also fall back. And there's my linear line. So how many solutions do I have? How many points would they intersect? That would be none. All right, 19. Remember who has this one. So you'll have to check your package of papers and check and see. First question is, what is the y-intercept of the graph? So here's your y-intercept. So it is at 80, so 0, 80. So to explain, well, it's on the y-axis over there. Next thing we've got is, what does the y-intercept represent in the content of the situation? You can see it's talking about height in feet, so that would be the starting height for the ball. After how many seconds did the ball reach its maximum height? Well, right up here is its maximum height. Seconds, look down here, it would be 2 seconds. How do I know that? Went and found my maximum point up there, followed it down to the x-axis, which would give me my maximum height. All right, next question. What is the maximum height in the feet? So now I'm going to look over to my y-axis up there, and it is 144 feet. So the ball goes as high as 144 feet. Again, I'm using the graph to help. After how many seconds did the ball reach the surface of the river? Now we're looking at the x-intercept. So it is going to hit the water 5 seconds later. Okay, next one. The table below shows the height of a rocket at different times. Now, I know first period and fourth period, you both have this one. Write a function that gives the height of the rocket y after x seconds. So you are going to go to your stat edit. You're going to go ahead and put in those numbers, 0, 0.5, 1.5, 2.5, 3.5. Okay, and then over on the other side in your L2, you're going to go ahead and put in the height. And then you're going to go ahead and hit stat calc, and you're picking that number 5 for quadratic regression. Hit your enters quite a few times, and we end up with y equaling negative 16x squared plus 64x. All right, so we can see just how the velocity of the rocket was 64 feet per second, and we have our gravity. It says at what time does the rocket begin its descent. So we're looking at its maximum point. So we want to see where it would be at its highest spot. You could graph it and look at it if you wanted to, or since it's asking for the max, at what time is our x, you can do opposite of b, which would be negative 64, over 2 times our negative 16. So opposite of b over 2a, we get from that negative 64 divided by negative 32, which gives us 2 seconds. So at what time does the rocket begin its descent? Once it hits that 2 seconds, it's going to start to come back down. What is the rocket's total flight time? Total flight time, we want to know when does it land. Well, it started off the ground because we had no C. And now we want to know when it's going to land. So we're going to go ahead and take negative 16 and plug in what? Am I setting it equal to 0, or am I plugging 0 in for x? We want to know flight time. So remember I told you yesterday, the day before, flight time. If we want to know time, that's the x. So we're given the height of 0, so we're going to set this equal to 0. Now you can factor this and take out a negative 16 first and an x. That would leave me with x minus 4. And then we've got negative 16x equals 0. We have x minus 4 equals 0. Over here, when you divide, you're going to get x is 0. Well, that's when the rocket was started. It started from the ground. Over here, we're going to get x equals 4. So it took 4 seconds for it to land. All right. And I believe that was the last problem. So hopefully y'all are ready and good for your test tomorrow. Please be on your best behavior. Make sure you keep your eyes on your own paper. No talking, and do the absolute best you can. You will have an opportunity first period and third period to do test corrections on Monday and Tuesday. So everyone, please take your time. Make sure you're doing everything right. Get that test done and have a fabulous weekend.